All right. Today we're going into where covalent bonding kind of gets tricky. Um, so far we've been talking about molecules that, form bonds to get 8 outer shell electrons. Really, we call that the octet rule because everything's aiming for 8, once again, except hydrogen and helium. So today we're looking at what do we do when we need to break the octet rule. Um, some of these elements, some nonmetals, want other elements, electrons, way more than like the electron donor. So they're able to force some things to break the octet rule, if you will. I think the best way to do this is just to kind of jump into it. So let's start off here. PCl5, phosphorus, 5 chlorines. If I want to name it, phosphorus pentachloride. So the first thing I do is just like how we did the drawing stuff before, I'm going to draw versions of it kind of over here. And since we're dealing with a lot more things, I'm probably going to need a lot more room. All right, phosphorus. I'm not going to show my periodic table anymore. You should have one you can check. Phosphorus, 5 outer shell electrons. What that's going to look like is it's essentially going to have 1 pair of electrons, 3 unpaired electrons, each forming a bond. My chlorines are in column 7. They're each going to have 3 pairs of electrons and want 1 bond. So if you give me a second to do that, these guys I'm going to draw this way, just so I can start manipulating bonds. All right, let's just start off pretty basic. Let's have this chlorine kind of come around and do that one. And this chlorine, we can go here, not there. We'll have this chlorine go about yonder. All right, so 2 of my 5 chlorines are taken care of. Let's take care of a third one here in kind of the most obvious way. Have it go to that bond there. All right. Right now, 3 of my chlorines are happy. My phosphorus right now happy, but I have these 2 chlorines here. Now, PCl5 tells me this all forms one molecule. If I kind of looked at this and then kind of drew these 2 together, I have 2 molecules. I have PCl3 and a Cl2 molecule. So that's not going to work for this formula. That means I need to find a way to get these 2 chlorines into this phosphorus. This phosphorus, though, doesn't have any more bonds it can give. But it does have 2 electrons. And really, all that this bond means is that this chlorine's looking for an electron to share. And these chlorines are actually kind of bullies in that they're actually going to force that phosphorus to share, to break up that pair of electrons. The phosphorus doesn't really want to, but the chlorines are really persuasive in talking it into sharing that. All right, this though looks like a jumbled up octopus mess. So I need to draw this a lot better. And it looked like everything had connected to that phosphorus in the middle. So let's just pop a phosphorus right there. So now when I go through this, I have 1, 2, 3 chlorines. We actually have 5 chlorines. So let me even just draw 5 different bonds coming out here. And each one we said was to a chlorine. So I know I can just pop chlorines at the end. However, I can't stop here. The pairs of electrons the chlorines have are still important. Every single one of these chlorines has 3 pairs of electrons on it. So now I just need to go through, pop those 3 pairs of electrons on. If you're wondering why we do this, it's important to see where these pairs of electrons are, because these pairs of electrons are going to want to spread out all of the kind of different groupings on this chlorine, but these electrons are also going to push against the electrons on other chlorines. So it's going to really force this into a very specific shape, which we're building up to. All right. So now this phosphorus, so, breaking the octet rule, where does that come in? This phosphorus now looks like it has, each covalent bond stands for 2 electrons. 2, 4, 6, 8, 10. This phosphorus looks like it has 10 outer shell electrons. that phosphorus is actually kind of okay with that. I mean, the chlorines are all happy. Chlorine, if we're looking at chlorine, fluorine, uh, and oxygen, they really, really, really want other atoms' electrons. We're going to talk about that in class. So yeah, so this is it. This is all I had to do for that. All right, SO3. We're going to look at one that's a little bit tougher. All right, so I've got a sulfur, column 6, so 6 outer shell electrons. I have 3 oxygens. Let's go 1, 2, 3. They're also in column 6, so they're going to look just like my sulfurs. I'll just put them in a line like that. All right. So they both want 2 electrons. So oxygen, though, really, really, really wants electrons way more than sulfur does. The reason I know this is sulfur has 3 electron shells, oxygen has 2. So there's less stuff in the way between the oxygen's nucleus and other electrons compared to the sulfur's nucleus and other electrons. All right, so starting off this way, starting off how I have ovaries done, let's just start by... So, one of the things you might think you can do is go here to there, here to there, do that, and do that. That, works. That follows all the rules we have and stuff. One of the big issues, though, is your molecule tends to look something like that. Squares are really hard to find out in nature. So that's probably not going to work. Essentially, like you can form pentagons, okay. Squares and triangles like that, you're not really going to find. So there's probably a better way to do this. So I know I'm not going to probably bond any of these oxygens to each other. But each oxygen then wants 2 bonds. So let's just see what happens if I double bond that oxygen to that sulfur. Okay, my 2 electrons together, we're looking for 4 different bonds for 4 different electrons to bond to. I look at my sulfur, it has 4 other electrons it can share. So let's go share that electron, come around, make this messy, share that electron. Okay, not doing bad. And let's go up to that electron. And it looks like I only have 1 left. Right there. All right. Really a mess here. So let's look like my 3 oxygens were bonded to the sulfur. So I can go sulfur. Looks like we just have 3 sets of double bonds. 1, 2, 1, 2, 1, 2. So I can even just go double bond, double bond, double bond. Each of those was to an oxygen. And each of those oxygens had 2 pairs of electrons. All right, so now sulfur looks like it has 2, 4, 6, 8, 10, 12 electrons around it. This one really breaks the octet rule, but it works. If I wanted to draw it kind of more naturally, I could break my sulfur, kind of do thirds around it, and then spread those electrons apart on the oxygens. Both of these are right. That's breaking the octet rule. Some of them it's really easy to see once you get started whether you're going to have to break the octet rule or not. But we have practice, so we can kind of figure this out. So good luck with that.